Hello students. Welcome back to my channel, the Goddess of Econ. The topic that I will cover today is Macaulay duration, which many beginners in finance find very difficult to grasp. Why? Well, because its definition is something like the following. Macaulay duration of a bond is the weighted average time to maturity of the cash flows of a bond, where each cash flow is weighted by its present value, discounted using the yield of the bond. Of course, there are other more sophisticated versions of the Macaulay duration definition in English, which I will not show here for your mental well-being. Anyway, many beginners in finance would not be able to understand what it is, just by reading the definition above. And I believe this kind of wording can confuse you beginners even more, so I suggest that you disregard it for now. In other words, let's forget about it. Next, let's turn to the mathematical definition of Macaulay duration. Looks quite complicated, doesn't it? I times coupon divided by 1 plus r to the power of I, and after summing each of them up, you also add n times principal, divided by 1 plus r to the power of n. And then, you again divide the whole thing by the bond's price. What does all this mean? Especially for those students who are not mathematically minded, this darn formula may look almost incomprehensible. Frustrated? Well, don't worry too much. That's why I am here. The Goddess of Econ has come down to earth, to enable every single one of you to get a good sense of what it is. To achieve that, let's examine some simple examples together. Okay, here is a bond with notional $100, coupon rate of 3% per annum, paid annually, with maturity of 3 years. Let's also assume that the bond is currently priced at par, for simplicity. Then, Macaulay duration of this bond can be calculated as follows. Well, it doesn't look too messy, does it? If you just focus on the expressions in the numerator of the small fractions, you will see that each coupon amount is being multiplied by time weights. That is, the first year coupon amount is multiplied by 1, the second year coupon amount is multiplied by 2, and the third year coupon amount is multiplied by 3. What's more, the redemption amount in year 3 is also multiplied by 3, along with its coupon amount. What this suggests is that this formula assigns higher weights to the cash flows that are occurring later, rather than earlier. You can see that the cash flow in year 1 gets a weight of just 1, but the cash flow in year 3 gets a weight that is 3 times higher. And more importantly, given that the whole redemption amount in year 3 gets the highest weight as well, it would be natural for the Macaulay duration to be skewed towards the last weight of 3, which is the year in which the bulk of the cash flows occurs. Now, let's find out how long or short the Macaulay duration is in this case, using the equation shown. What do you think? It is quite close to the maturity of the bond, as we expected, isn't it? By the way, the YTM of 3% was used for the values of r in the equation above, as the bond was assumed to be priced at par. Now, if you look at the equation once again, you may also be able to conjecture that, if more cash flows occur relatively earlier, for example, if the coupon amounts evenly distributed between year 1, 2, and 3, become larger, the Macaulay duration will become shorter. This is because the relative size of the earlier occurring cash flows getting time weights of 1 and 2 are now a little bigger than before. Let's find out if this is really the case. Okay, let's assume that the bond's coupon is now twice as large, that is, 6% with every other condition remaining the same. Based on the new cash flows, the Macaulay duration is now calculated to be. Wow, as expected. The duration has gotten shorter than before. Last time it was 2.91 years. In order to check the impact of coupon level on Macaulay duration, let's look at another example. This time, let's increase the coupon further to 10%. Then, we have 2.74 years. This is significantly shorter than 2.91 years when the coupon rate was just 3%. Okay, just to make sure, let's look at another example. This time, let's do the reverse. That is, let's look at the case where the bond pays only 1% coupon. Will Macaulay duration be longer than in the past examples? Here is the calculation. Wow, as expected. The Macaulay duration of 2.97 years here is very close to the bond's maturity, 3 years. This is because almost all of the cash flows are occurring in the last year, that is, year 3. Lastly, let's take a look at an extreme case where the bond pays no coupon at all. The Macaulay duration calculation in this hypothetical case would be as follows. If you plug in 0% for the value of r in the equation, you get. Wow. Macaulay duration in this extreme case becomes exactly 3 years, the same as the bond's maturity. This is because all the cash flows are occurring in year 3, which is assigned a time weight of 3. There is no cash flow occurring in years 1 and 2, which would have received time weights of 1 and 2, respectively. Therefore, it can be said that the bonds paying no coupon in the interim but paying a lump sum only at maturity have Macaulay duration exactly equal to its maturity, expressed in years. So, in summary, the higher the coupon, the shorter the Macaulay duration of the bond becomes. Conversely, the lower the coupon, the longer the Macaulay duration of the bond becomes. And in the case of zero coupon bonds where cash flow only occurs at maturity, Macaulay duration becomes exactly equal to its maturity, expressed in years. So, Macaulay duration can be thought of as the weighted average time to maturity, with weight of 1 given to cash flows occurring in year 1, weight of 2 to year 2, and so on and so forth. In the case where the cash flow occurs only at maturity, the weighted average time to maturity becomes just plain maturity. Not too difficult, is it? Before closing, I would like to note that Macaulay duration is less frequently used in practice than its cousin, modified duration. The concept of modified duration is a lot more important in the field of finance than Macaulay duration. Hence, in my next finance lecture, I will cover the concept of modified duration. So, please do visit again, and don't forget to like and subscribe before you go. May God bless you all.